Unexpected questions often come to people's head. As a baby grows up, it thinks about things that are later treated as elementary, such as, why does a butterfly fly? Why do leaves fall? And what makes the sun shine? But adults have more tricky questions. It's not enough for them to know that the star warms the Earth and to be happy about it. Adults want scientific evidence of the process, and then the unstoppable imagination begins to draw incredible pictures and demand their implementation. For example, some people seriously wonder what would happen if the sun were to explode and whether it could somehow be extinguished. Let's omit the question of the expediency of this action and say at once, not with our talents or the capabilities of humanity. In other words, human civilization has not yet reached the level where it could control the life of its own heavenly body as it wishes. And that's fortunate because we don't let young children play with matches. However, no one prevents us from thinking about it, especially since even some scientists have asked similar questions at different times. Our sun is a yellow dwarf, a main sequence star, and a relatively stable heavenly body with an average lifespan of 10 billion years. Without this modestly sized star, by the universal standards, the existence of a habitable Earth is unthinkable. Accordingly, to provoke a sun explosion would be not only extremely reckless, but just think, how to blow up the thing that the last 5 billion years is almost in a state of constant detonation. German astrophysicists from the Max Planck Society 16 years ago tried to find out why some stars explode and not fade out themselves. To do this, they used a powerful computer for modeling and systematized the observational data related to the emergence of supernovae. When Ewald Müller and Wolfgang Hillebrand attempted to understand what causes the colossal explosion that lights the bright celestial objects of supernovae, there were many difficulties during the explanation. Computer modeling of the detonation process instead of the expected explosion gave information that the star turned on a self-regulating mechanism that allows it not to explode, but quietly fade. Later, by adding new inputs missed earlier, the process, although simplified, was still considered in detail. One thing is certain: whatever type of star explodes, something must cause the detonation. An approaching critical mass, an uncontrolled nuclear reaction, a sharp drop in gas pressure, an instant collapse of the core, or all of them together. How can mankind influence the sun? At this point, it is ridiculous to even talk about it. Digging into the planet's nuclear arsenal, it's easy to figure out that the most powerful weapon we can offer, the sun, is hydrogen bombs. Let's assume that our spaceships somehow miraculously carry a few 50 megaton Tsar bombs to the surface of the sun and pass unimpeded through its corona, whose temperature reaches 1,000,000 degrees Celsius. What will we get from these pathetic explosions, considering that the sun regularly emits plasma with a cumulative power of over 1 billion megatons up to 20 times a day? Earth's stings would be akin to an ant crawling on an elephant's back. What if we did it the other way around? Since we've safely escaped the deadly solar corona, we can dare to put the detonator inside the sun. Wrong again. If the impossible scenario comes true, the sun's stabilizing mechanism will not allow even the slightest malfunction. When something like this happens for natural reasons, the star immediately engages thermoregulation and the situation is instantly normalized. Otherwise, the sun would not have lived its 5 billion years. The same would happen in the case of detonation of Earth's bombs. Our star is an amazing creation of the cosmos, without which life on Earth is impossible. So the very idea of destroying it is absurd. Moreover, it is ridiculous. because we have nothing to oppose a huge torch with a diameter of 1,392,000 kilometers, burning 700 billion tons of hydrogen every second. With such an active loss of matter, the sun should have burned out long ago, but some process keeps this giant furnace going for a long time. What is it? It's a thermonuclear reaction going on in the core of the star, constantly energizing it. It turns out that we're thinking about detonating a bomb on the surface of the bomb. Nonsense, isn't it? But detonation isn't the only way to destroy a star. What if we use other methods and extinguish the sun? In fact, in order for our sun to go out, we need to either cool it down or stop the thermonuclear reaction in its interior. The second will happen by itself after 4 to 5 billion years, when the process of transformation of hydrogen into helium subsides. But to cool the sun can be tried with the help of artificial expansion of its area. For example, by pulling a neutron neighbor to our star. Then the sun will have to share its matter with her, and it will gradually turn into a dim white dwarf. There is another extravagant way to try to water the sun from a Titanic fire sprinkler, although this is not only fabulous, but also absolutely useless option. Water will simply evaporate without a trace still in the crown, and did not reach the star, because no one in his right mind will not water the forest fire from a garden watering can. But, as it turns out, we are not the only ones who came up with such a crazy idea. Astrophysicists found out this. If you pour on the star volume of water equivalent to 70% of the mass of the sun, the effect will be quite the opposite. The luminary is not only not extinguished, but will ignite even more. At the same time, the sun will increase in size by 1/3 and 6 times in brightness. Let's move away from explosions and cooling and look at collisions between the sun and large celestial bodies. In our star system, the most likely candidate is Jupiter. Compared to the sun, of course, it is extremely small, but still quite huge. The consequences of collide will not be so serious as to blow up or extinguish the star. On the contrary, the sun's luminosity would probably increase somewhat. The kinetic energy imparted by Jupiter as it falls onto the star's surface is unlikely to make it look like a pebble thrown into a swamp, because not only light gases will meet the impact. The iron core of the giant is 3 times the size of the Earth. In any case, the luminary will not extinguish and will not explode. But the consequences for our planet in such a cataclysm is difficult to predict, no matter how you look at it. But the idea of destroying the sun, outright insanity. It's like soaring down the tree you're sitting on. You can hide the sedatives, take a deep breath, and finally get out of the bunker. Because humanity can't destroy the sun in the next 1,000 years. Give us thumbs up if you think so too, because Hubble, together with the sensible viewers, wishes our star many years to come.